Welcome back for another deep dive. Psychology is on the menu for today.
Sounds fascinating.
We're using excerpts from David G. Meyer's book, Psychology, ninth edition,
Oh,
specifically chapters 6 and 7, covering sensation and perception
right.
and learning. We'll uncover how our brains make sense of the world around us
I see.
and how we learn, from optical illusions to the phenomenon of taste aversion.
I've always found that so interesting. Taste aversion.
Yeah, so have I. One thing that stood out to me from the book is how perception isn't just this passive process
Yeah.
of us absorbing information.
Right.
It's actively constructed by our brains.
That's right. Yeah. Our brains are always working behind the scenes
Wow.
to weave together information from our senses
Okay.
with our past experiences, expectations, and even our emotions.
So our brains are kind of like filling in the blanks that
Exactly.
based on what we already know
Yeah.
and what we anticipate.
Precisely. A really powerful example of this is the influence of context. Myers talks about this illusion called the magician's cabinet. It's figure 6.47 in the book.
Okay.
And the same box can appear to be either sitting on the floor
Wow.
or hanging from the ceiling, depending on the surrounding image of rabbits.
I remember seeing that illusion in the book.
Yeah,
It's amazing how easily our brains can be tricked
it really is.
by the context.
Yeah.
What are some of the implications of this for us in everyday life, though?
Well,
I mean, if something as basic as spatial orientation can be so easily flipped,
right.
what else might we be misinterpreting?
Well, think about how we judge distances, for example.
Okay.
Research shows that distances can seem longer when we're tired,
Uh-huh.
or a hill can look steeper when we're carrying a heavy backpack.
Interesting.
Our internal state actually influences how we perceive the external world.
I've definitely experienced that. It makes you wonder
Yeah,
how much of what we perceive is truly objective reality
right.
and how much of it is being shaped by all of these internal and external factors.
That's right. It raises some really important questions
Yeah.
about how much our individual experiences and even our cultural backgrounds
Right.
can shape the way we see the world.
It's like we're all walking around with our own personalized filters then.
That way, yeah.
So if our brains are constructing these perceptions, does that mean it's all nurture,
Right.
learned through experience?
Uh-huh.
Or is there a nature component too? Are we born with any perceptual abilities?
That's a debate that's been going on for centuries.
Wow.
And as with many things in psychology, the answer seems to be both.
Oh.
Studies of people who were born blind, but then gained sight later in life,
Oh, wow.
give us some interesting clues.
So they're experiencing the visual world for the first time as adults.
Yes.
What did researchers learn from these cases?
Well, these individuals could distinguish figure from ground immediately,
Okay.
and they could see color,
Uh-huh.
suggesting these abilities might be hardwired, but they really struggled to recognize objects that they knew by touch,
Interesting.
like a key or a cup, for instance.
So they had the basic visual machinery,
Right.
but their brains hadn't yet learned to make sense of it,
Exact.
to interpret and categorize those signals.
It highlights the really important role of experience in shaping perception,
Wow.
which is what the philosopher John Locke theorized.
Makes you wonder how much we take for granted, you know?
It really does.
Speaking of taking things for granted,
Yeah?
what about our ability to adapt to changes in our perception? Like, could we actually adjust to seeing the world upside down?
Well, that's exactly what researchers wanted to find out.
Really?
And they found that unlike chicks, for instance,
Okay.
humans can adapt surprisingly well to distorted visual input.
So they had people walking around with upside down glasses.
Pretty much. They had people wear glasses that flipped their vision.
Wow.
It was disorienting at first, of course,
I bet.
but they learned to function.
Really?
They could walk, ride a bike, even read,
That's incredible.
all while seeing the world upside down.
Our brains are so much more flexible than I realized.
They really are.
So what happened when they took the glasses off?
Well,
Did everything just go back to normal?
not quite. There's this phenomenon called the after effect,
Okay.
where after removing the glasses, people would make temporary errors,
Yeah.
but in the opposite direction.
Interesting.
So things would appear upside down for a little while,
What?
even though they were actually right side up.
That's so strange. It's like their brains had recalibrated to that
Yeah.
upside down world.
Exactly. It shows how plastic the human brain really is. Its ability to rewire itself
Okay.
and adapt to new input.
It's not a fixed system then.
No, not at all.
That's encouraging to know.
Yeah.
Especially when you think about all the challenges our brains might face.
Right.
And their ability to adapt and even compensate for damage.
Absolutely.
So we've been talking about how we perceive the world. But what about how we learn? I think everyone's heard of Pavlov and his dogs.
Right. Ivan Pavlov's work on classical conditioning was groundbreaking.
It really was.
It showed that learning can occur through association, where two stimuli become linked in our minds.
It's interesting to think about how that plays out in everyday life.
Yeah.
Can you remind us about the key concepts?
Sure.
I vaguely remember something about unconditioned responses and conditioned stimuli.
Right. Let's use the classic example of Pavlov's dog.
Okay.
The food is the unconditioned stimulus, or the US.
Okay.
It's the thing that naturally triggers the salivation response, which is called an unconditioned response.
Gotcha.
Or the UR.
Right.
No learning needed there. That's just a natural response.
That makes sense.
But initially, the bell is a neutral stimulus.
Okay.
But Pavlov repeatedly paired the bell. Now the conditioned stimulus, or CS, with the food, or the US.
Okay.
And eventually the dog started to salivate at just the sound of the bell.
Wow, that's amazing how powerful those associations can be.
It really is.
But wasn't there a researcher who challenged the idea that any association could be learned equally well?
Yes, you're thinking of John Garcia.
Oh, right, John Garcia.
And his research on taste aversion, which really changed how we think about learning.
Can you tell us more about Garcia's work?
Sure. So Garcia was studying the effects of radiation on rats.
Okay.
And he noticed they started avoiding the water in their cages.
Really?
He discovered they had developed an aversion to the taste of the water, even though they got sick from the radiation hours later.
So they associated the taste with the nausea, even though it wasn't the taste that actually made them sick.
Exactly.
Which kind of contradicts the idea that the unconditioned stimulus needs to happen immediately after the conditioned stimulus for learning to occur.
That's right.
And what's even more remarkable is that they developed the aversion to the taste, but not to any sights or sounds that were associated with the radiation.
Exactly. And that makes sense from an evolutionary perspective. For a rat, taste is the most reliable indicator of whether food is safe or not.
That's true.
Yeah.
So Garcia's work showed that biology plays a huge role.
It does.
In what we're predisposed to learn.
Yes.
We're not just blank slates waiting to be written on.
Right.
We have certain biological predispositions that make some associations easier to learn than others.
Exactly.
I know I've experienced taste aversion before. Like if I get sick after eating a certain food, I still can't even look at it for a long time.
Yeah.
Even if I know it wasn't the food that made me sick.
That's a perfect example.
It's such a powerful survival mechanism.
It really is.
It's like a built-in safeguard.
Right.
To protect us from things that might be harmful.
Absolutely.
It's incredible how these learning mechanisms have such profound implications for our survival.
It is.
But learning isn't just about avoiding danger, right?
No, not at all.
It also plays a big role in, well, more pleasurable activities.
Yes. It helps us navigate the world, adapt to new situations, and even find mates.
Interesting.
There's an example in the book about Japanese quail.
Okay.
Researchers paired a red light with the appearance of a receptive female quail, and the males quickly learned this association.
So they associated the red light with the possibility of mating.
Exactly. And they were much quicker to mate.
Wow.
And even produced more sperm.
Wow. That's a reproductive advantage.
Absolutely.
It's fascinating to see those basic learning principles playing out.
It is.
In the animal kingdom.
Yeah.
Do you think there are any parallels in human behavior?
There's research to suggest that men might be predisposed to find the color red attractive.
Interesting.
Because of its association with female sexuality throughout evolutionary history.
It's like red lipstick.
Exactly.
A red dress.
Uh-huh.
That's pretty interesting.
It is.
Makes you wonder how many of our preferences and behaviors are rooted in these ancient evolutionary mechanisms.
It's a fascinating question.
That
continues to fascinate psychologists.
So what's clear is that learning plays a crucial role.
It does.
In shaping who we are and how we interact with the world.
Absolutely. And we're not just talking about memorizing facts.
Right.
It's about how we adapt and respond to everything around us.
Exactly.
Yeah.
And on that note, it's important to remember that classical conditioning is just one type of learning.
It is.
There's also operant conditioning.
Right.
And observational learning, which we'll delve into later.
Yes, there's still so much to explore.
We've already covered so much.
We have.
And it feels like we're just getting started. This deep dive is really eye-opening.
It is.
I can't wait to learn more about the other types of learning.
Me too.
So far, we've been exploring how we learn by associating things.
Yeah.
But what about when we learn based on the consequences of our actions?
You're talking about operant conditioning.
Right.
It's different from classical conditioning,
Okay.
where the focus is on automatic responses to stimuli.
Right.
Here we're looking at voluntary behaviors, shaped by the rewards or punishments that follow them.
So it's less about just reacting to the world and more about learning to act in ways that lead to certain outcomes.
Right.
Makes sense.
I think a good example of this is how you train a dog.
Oh, yeah. Using treats.
Exactly. That's a classic example of positive reinforcement.
Okay.
You're giving your dog a treat for doing something you want it to do.
Right. Like sitting or staying.
Precisely.
Or shaking paws.
That's right. And the treat serves as a reward, which then strengthens that behavior.
Okay.
Making it more likely to happen again.
It's amazing how effective it can be.
It is, yeah.
What about punishments, though?
Yeah.
How do those fit into operant conditioning?
Think of a punishment as any consequence that makes a behavior less likely to occur again.
Right.
Like getting a speeding ticket, for example, that's designed to discourage speeding in the future. That would be positive punishment.
Okay.
Where something unpleasant is added to decrease a behavior.
So wasn't there a researcher who really dove deep into this?
You're thinking of B.F. Skinner.
Right, B.F. Skinner.
He was a pioneer in this area.
What did he do exactly?
He designed these really clever experiments using what he called operant chambers, but they're often called Skinner boxes.
Skinner boxes, okay.
Oh.
What were those like?
Imagine a small box with a lever or a button that an animal can press, often a rat or a pigeon. And if the animal happens to press the lever, it gets a reward, like a food pellet.
So there's no explicit training?
No.
The animal just figures it out on its own.
That's right, by exploring the box and experiencing the consequences.
That's amazing.
It is, yeah.
It makes me think about how addictive social media can be.
Oh, interesting.
We're constantly checking our phones for those likes and comments.
That's a great comparison.
And messages, too.
Yeah, social media platforms are designed to give us these intermittent rewards. And that makes it really hard to stop those behaviors.
Like checking and scrolling.
Yeah.
Even posting. It's like we're conditioned to keep coming back for more.
Exactly. Even if the rewards aren't all that frequent.
So we've talked about rewards and punishments, but what are some of the other key concepts?
Well, Skinner identified different types of reinforcement. Anything that strengthens a behavior. We've talked about positive reinforcement.
Right, adding something desirable.
That's right. But there's also negative reinforcement, which is taking away something undesirable to strengthen a behavior.
I'm not sure I follow.
Let me give you an example. Think about taking an aspirin for a headache. Taking the aspirin removes the headache, which then reinforces the behavior of taking aspirin in the future. I get it.
So both positive and negative reinforcement increase behavior.
Yes.
Just in different ways.
Exactly.
What about punishment?
Well,
are there different types of that too?
Yes. There's positive punishment, which is adding something undesirable.
Like a reprimand.
Right, or a fine. And then there's negative punishment. Which is taking away something desirable. Like a child's favorite toy. As a consequence of bad behavior.
So we have positive and negative reinforcement, which strengthen behaviors. And positive and negative punishment, which weaken behavior.
Exactly.
I feel like timing must play a big role, too.
It does.
Does it matter when the consequence happens?
Yes.
In relation to the behavior?
Absolutely. Skinner found that different schedules of reinforcement can really affect how a behavior is learned and how resistant it is to extinction. There are two main categories. Continuous reinforcement and partial reinforcement.
Could you explain those a little more?
Sure. Continuous reinforcement is when a behavior is reinforced every time it happens.
So it's like a consistent, predictable reward.
Exactly, like a vending machine.
Oh, yeah, you put in the money.
Right.
You get the snack every time.
Precisely.
Okay, what about partial reinforcement?
Well, that's when the behavior is only reinforced some of the time. This can happen on different schedules. Like a fixed ratio schedule, where a behavior is reinforced after a specific number of responses.
Oh, I get it. Like those coffee shops.
Yeah.
Where you get a free drink after you buy 10.
That's right.
And then there's also the variable ratio schedule.
Right.
Where the behavior is reinforced after a random number of responses.
Exactly.
That's like slot machines. You never know when you'll win.
Precisely. That unpredictability is what makes them so addictive. Because you keep coming back for more.
It seems like this type of reinforcement schedule is really powerful.
It is, yeah.
In shaping behavior.
Variable ratio schedules are very effective at creating persistent behaviors.
It's interesting to think about how our lives are filled.
It is.
With these subtle reinforcement schedules
that
are shaping our behaviors without us even realizing it. But is it all just about rewards and punishments, though? Don't we also learn by watching others?
You're talking about observational learning or social learning is a crucial way we learn.
It is, especially for humans.
Yeah.
So we can pick up new things just by observing other people.
Exactly.
And the consequences of their actions.
Right.
We don't always have to experience everything firsthand.
No, not at all. Think about how children learn.
Yeah, they watch their parents, their siblings, their friends.
Right, and then they imitate what they see.
Didn't researchers find that there are special brain cells?
You're thinking of mirror neurons.
Right, mirror neurons.
They fire both when we do an action.
Yeah.
And when we see someone else doing that same action.
They've been called the neural basis of empathy.
Yes, because they help us understand the actions and intentions of others.
It's like our brains are simulating the experience of doing that action ourselves.
Exactly. And that simulation allows us to learn without actually having to go through trial and error.
So observational learning can save us a lot of time and effort then.
It can, yes.
Wasn't there a famous experiment
that
showed how powerful observational learning can be?
Albert Bandura's Bobo doll experiment.
Oh, right, the Bobo doll.
It's a classic study.
What were the details again?
Well, they showed kids a video of an adult interacting with this inflatable doll.
Yeah.
Some kids saw the adult act aggressively, punching and kicking the doll, yelling at it, while other kids saw the adult ignore the doll and play with other toys instead.
So I'm guessing the kids who saw the aggressive adult were more likely to be aggressive themselves.
Exactly. They imitated those actions.
Wow.
Which really shows the impact of modeling on behavior, especially in children.
It's a little unsettling to think about
Yeah.
how easily we can be influenced.
It is, yeah.
By what we see around us.
Especially during childhood.
But observational learning doesn't always have to be negative, right?
No, of course not.
We can also learn things like kindness, empathy, helping others.
Absolutely, it can have both positive and negative effects.
Depending on the behaviors being modeled.
It's a powerful force in shaping who we are.
Yeah.
And how we interact with the world.
So we've explored classical conditioning, operant conditioning, and observational learning.
It's amazing to see how they all interact.
It is.
And shape our behavior.
What's even more remarkable is that learning isn't just a one-time thing. It's an ongoing process.
Right, it happens throughout our lives.
We're constantly adapting and updating what we know. Based on our experiences.
Right.
And this adaptability is possible because our brains are so plastic.
Exactly. Our brains can change and grow. Wow. Throughout our lives.
So what are some key takeaways about learning? What should our listeners be thinking about?
I hope they come away understanding that learning is fundamental to our survival.
Right.
It helps us make sense of our experiences, navigate the world, and connect with each other.
And we've seen that learning is far from passive.
That's right.
It's about actively engaging with the world.
Yeah.
Making those associations.
All right. Experiencing the consequences. And observing others.
And because of that, we have some control over what we learn.
Right.
And how we behave.
We can choose to be around positive influences.
Okay.
Reinforce good behaviors. And create environments that support learning.
That's really empowering.
It is, yeah.
It inspires me to be more intentional about what I'm learning and the behaviors I'm modeling for others.
That's great.
What's next?
Well, we've talked about learning, but what good is learning if we can't remember what we've learned?
Right.
So next, we're going to delve into the fascinating world of memory.
Okay, I'm ready.
Yeah.
But before we do that, let's take a second to acknowledge that we've just scratched the surface here.
We have. There's so much more to psychology.
Right. And I encourage everyone listening to keep asking questions.
Yeah.
Keep learning.
Keep exploring.
And never stop being curious about your own mind.
Absolutely.
After all, understanding ourselves is a huge part of understanding the world around us.
It is.
So let's shift our focus now to the amazing realm of memory.
Right.
How do we encode, store, and retrieve information? Okay, memory.
Yeah.
It's incredible how our brains hold on to so much information.
It really is.
Everything from like random facts to important life events.
It's remarkable, and memory isn't just one thing.
Okay.
It's a whole system of interconnected processes.
That makes sense. It can't be as simple as storing files like a computer. Speaking of computers, though, I remember learning about the information processing model.
Yeah, that's still a helpful way to think about it.
Okay.
It highlights the stages involved.
Right.
Encoding, storing, and retrieving information.
So it's like our brains are constantly filtering this stream of information.
Yeah.
And deciding what's important enough to keep.
Right. Our brains are incredibly selective.
They are. We're bombarded with sensory input all the time.
We are.
How does our brain choose what to actually encode and remember then?
We tend to remember things that are meaningful to us.
Okay.
Or things that have an emotional impact.
That's true.
Things that connect to what we already know.
Yeah, I can definitely relate to that.
Yeah.
I can remember vivid details from my wedding day.
Yeah.
But I can barely remember what I had for dinner last night.
That's a good example.
Emotions seem to play a big role in what we remember.
They do. Emotion acts like a highlighter.
Okay.
Making memories more vivid and lasting.
And we also use different strategies to encode information, right?
Yes, like repetition.
Right.
Connecting it to existing knowledge.
Right.
Creating visual images.
So it's not just passively absorbing it.
No.
It's actively working with it.
Exactly.
And making it meaningful.
That's right.
Once we've encoded that information, where does it go?
That's where storage comes in.
Okay.
Storage is how we hold on to information over time.
And just like a computer has different types of memory.
Yeah.
Like RAM and hard drives.
Our brains have different memory systems too.
Okay, tell me more about those.
Well, first there's sensory memory. It's really brief.
Okay.
It only lasts a few seconds.
Okay.
It holds on to incoming sensory information.
So for all those sights and sounds.
Exactly. Smells, sensations.
Right.
It's like a temporary holding tank.
It gives our brain a chance to decide what's worth paying attention to.
Exactly.
What happens next.
Well, then there's short-term memory. It's what we use to hold on to information that we're actively thinking about.
Right. It's limited, though, right?
It is. Kind of like a small notepad.
I've definitely experienced those limits. Like if someone gives me a phone number.
Yeah.
And I don't write it down right away.
It's gone.
It's gone.
Yeah. Short-term memory is also called working memory.
Okay.
Because it's where we manipulate information, solve problems, make decisions.
So sensory memory grabs our attention.
Yeah.
Short-term memory lets us work with information.
Right.
What about long-term memory?
That's our vast, long-term storehouse of information.
Okay.
Everything from childhood memories to facts we've learned to skills we've developed.
It's incredible how much our brains can store.
It is. And fortunately, there's no limit.
Really?
Long-term memory has essentially unlimited capacity.
That's good to know.
And it's not static either.
Okay.
It's dynamic and constantly being updated.
So we've encoded information.
Yeah.
Stored it away.
Right.
Now, how do we get it back out?
That's retrieval. It's the process of accessing information from memory.
Like searching for a file on your computer.
Exactly.
But sometimes that search isn't so smooth.
That's right.
Sometimes I know something, but I just can't access it.
Yeah, like it's on the tip of your tongue.
Exactly.
That's a common experience.
It is.
And it shows how retrieval can be tricky.
Right.
It can be influenced by a lot of things, like what cues are available, our emotional state, even the context we're in.
So it's not just about whether the information is there.
Right.
It's about whether the conditions are right.
Exactly.
To access it.
And memory is a reconstructive process.
What does that mean?
We're not just replaying memories like a video recording. We piece them together based on the fragments we have.
Okay.
And those can be influenced by our current knowledge, our beliefs, even our expectations.
It makes you wonder how reliable memory really is.
It does, right?
I mean, if we're essentially reconstructing them each time,
yeah,
how can we be sure they're accurate?
It's true. Our memories aren't always perfectly accurate.
Wow.
They can be influenced by a lot of things. Leading questions, suggestions from others.
Okay.
Even our own desires.
To remember things in a certain way.
That's right.
It's a little unsettling to think about.
It is, but memory is still a powerful system.
Okay.
And while it's not flawless,
Right.
most of our everyday memories are generally accurate.
That's reassuring.
And there are things we can do to improve our memories.
Okay, like what?
One of the best strategies is to just pay attention.
Okay.
And really engage with the information.
Okay.
Use active encoding techniques.
Like what?
Repetition.
Oh.
Elaboration.
Okay.
Connecting it to things you already know.
So be an active learner.
Exactly.
Not just a passive one.
That's right.
What else?
Spacing out your learning is really important.
Instead of cramming.
Yes, cramming isn't good for long-term retention.
Makes
Spacing gives your brain time to process everything.
right.
And don't forget about sleep.
Sleep, okay.
Getting enough sleep is crucial for memory consolidation.
I'm definitely guilty of not getting enough sleep.
Yeah, it's important.
What else can we do?
Retrieval practice is key.
Okay.
Quiz yourself.
Uh-huh.
Try to recall information without looking at your notes.
Right.
You can even explain the concepts to someone else.
So the more we use our memories, the stronger they get.
Exactly. It's like exercising a muscle.
This deep dive has been incredible.
It has.
We've explored so much.
We have.
Perception, learning, memory.
It's been a great journey.
They really have.
I hope our listeners have a better understanding now
Yeah.
of how amazing the human mind is.
And how adaptable it is.
Absolutely. Our brains are capable of so much.
They really are.
Keep learning, keep exploring,
Yeah.
and never stop being amazed by your own mind.
Thanks for joining us for this deep dive into psychology.
It was a pleasure.
We'll be back soon with another fascinating topic,
We will.
exploring what it means to be human.